Read the problem. Analyze a given problem. Identify what it's asking for. Identify the values given by the problem which are useful. Obtain the function of distance in the y-axis. Derivate the function for distance using the definition of limits to obtain the function for velocity. Is the result for the velocity function correct? If no, go back. If yes, equal your distance to the function of 0. Solve for t. Is the time in which the ball reaches the ground correct? If no, go back. If yes, in the velocity function, substitute t for the time in which the ball reaches the ground. Is the result correct? If no, go back. If yes, use a formula for distance in the x-axis. Obtain the distance in which the ball reaches the ground. Is the result correct? If no, go back. If yes, to the result subtract the initial distance. Is the result correct? If no, go back. If yes, you're done.
Write down the equation of motion in the y direction of the ball. The position function is the following. So we only need to substitute our values that initial velocity is equal to 0 and initial height is equal to 100. So at the end we got minus 16t squared plus 100. This is our graph.
First, you have to use the main formula with the equation of motion in y direction. You must evaluate it with the limits. The limit h approaches to 0, f of x plus h minus f of x divided by h. Then you have to substitute the values and solve the polynomials, expand it, and then eliminate it. Then factorize the common factor, and you simplify h.
This is our graph.
Calculate the time it takes for the ball to reach the ground. To obtain the answer, we must use the equation of motion in the y direction, and our first step is to equal our function to 0 because it will reach the ground. Our next step is to isolate t in the function. This will end up with t being equal to 2.5 seconds.
Calculate the impact velocity in y for the ball. So we have that bt is equal to minus 32 time. So we only substitute our time, that is 2.5, in the equation, and at the end we have minus 80 feet over seconds.
How much distance does Mark have to run to catch the ball? In order to obtain the distance that Mark has to run, first use the formula of x equals to initial height times time. The initial height is equal to 50 feet over seconds, and our time is equal to 2.5 seconds. We substitute in the given formula to obtain x equals to 125 feet, and the last step is to subtract 50, since it is a measurement that Mark was standing in. And lastly, the answer will end up being 75 feet.
Calculate the time, that is t, 2 seconds, the position and velocity of the ball. You just have to substitute the 2, that is time, and the final answer is 64 feet over second.
So we can conclude that mathematics and physics are very similar scientific fields because they both help us understand our daily life. For example, we can use physics to know at what speed this ball will fall from this skyscraper. Also, we can use math to build the skyscraper in a durable way. We can also use physics to know how fast this car will go from this building to this one. We can also use physics to measure the electricity going through these lights and these lights. We can also know how long it will take for this guy to fall to the floor to die.